The antenna kept working perfectly, and that was exactly what made the noise impossible to explain. Nothing about the first readings suggested a historic discovery. A 20-foot horn antenna stood on Crawford Hill in New Jersey, doing the job it had been built to do. Arno, Penzias, and Robert Wilson powered up the receiver, compared its output against their expectations, and watched the chart recorder trace a clean line across the paper. The instrument behaved exactly as it should. Only one detail refused to cooperate. Every measurement carried the same faint excess. It was small, too small to look dramatic, but it stayed there. The antenna was built to listen with extreme precision. When it pointed away from obvious radio sources and toward empty regions of the sky, that unwanted signal should have faded. Instead, the extra noise remained. The horn could turn, the sky could change, and the pen still settled above the expected baseline. The first explanation was the ordinary one. Somewhere inside the receiving system, something had to be producing its own interference. The engineers treated the problem as a fault. Every cable, every connection, every component became a suspect. The receiver was then put through a stricter test. A reference source cooled with liquid helium was attached, allowing the instrument to compare the sky against a temperature already known with high confidence. If the receiver or electronics were drifting, that comparison should have exposed it. It didn't. The calibration held. That result pushed the problem outward. The receiver had become quiet enough that the remaining signal appeared to be arriving from somewhere beyond the instrument itself. The horn stayed where it was. The mystery moved past it. Now the search expanded into the structure around the receiver. Engineers inspected the waveguide, examined the interior surfaces, checked for losses that might have escaped earlier measurements, and looked for anything capable of scattering stray radio energy back into the system. Nothing explained the excess. The number barely moved. Another possibility was less elegant, but easier to believe. Living creatures had made themselves comfortable inside one of the most sensitive microwave antennas on Earth. 2 pairs of homing pigeons had settled inside the throat of the horn, leaving behind what Penzias later described, with careful technical restraint, as white dielectric material. The scene could hardly have looked less like the beginning of a revolution in cosmology. Brooms appeared. Scrapers followed. The pigeons were trapped and shipped to another part of New Jersey. They returned. The engineers removed them again, cleaned the interior thoroughly, scraped away every remaining trace of contamination, sealed openings where necessary, and restored the aluminum surfaces to pristine condition. Then they switched the receiver back on. The chart recorder traced the same stubborn offset. The pigeons were gone. The signal remained. By then, each successful repair had made the ordinary explanations weaker. The horn antenna was slowly exhausting every reasonable excuse. Attention shifted beyond the instrument itself. Perhaps the atmosphere contributed more microwave radiation than expected. Perhaps transmitters from New York City leaked enough energy to contaminate the readings. Different observing angles were tested. Different elevations, different times of day, different seasons. The excess did not follow any of them. The antenna looked through changing skies, through changing weather, across different portions of the heavens. Yet the additional background temperature stayed essentially unchanged. Day or night, summer or winter, horizon or overhead. Every direction answered with the same faint hiss. A local source should have changed as the antenna moved. This one refused. For months, the engineers narrowed the possibilities. Internal electronics had failed the test of suspicion. Structural losses had failed. Environmental contamination had failed. Birds had failed. Nearby civilization had failed. Even Earth's atmosphere could not account for what the antenna continued to hear. The instrument no longer looked defective. It looked honest. And that created a different problem. If the signal truly arrived from every direction, then it belonged to the sky itself. At almost the same time, only a short distance away at Princeton University, another group of scientists was preparing an experiment for a different purpose. Robert Dicke and his colleagues had been developing equipment to search for a faint remnant of an early hot universe, a prediction that suggested space itself should still glow with an ancient microwave background. The Bell Labs engineers were not searching for that prediction. They were trying to remove an engineering nuisance. A conversation connected the two groups. Bernard Burke, aware of work taking place at both institutions, recognized that the unexplained Bell Labs measurements might match what Princeton hoped to detect. When the data reached Dicke's team, the engineering problem took on a different identity. The annoying background hiss corresponded to the signal they had been expecting. Not from New Jersey. Not from the atmosphere. Not from faulty equipment. From the universe itself. The excess measured only a few degrees above absolute zero, roughly 3.5 Kelvin, spread evenly across the sky. What had looked like an unwanted offset became the oldest light anyone had ever detected, the cosmic microwave background, a faint thermal echo from the universe's earliest observable state. The horn antenna had not changed. Its aluminum walls were the same, its wide mouth still faced the sky, its job still seemed simple: collect microwaves with precision. But by the time the measurements were understood, that same structure no longer looked like a communications instrument struggling with interference. It had become the device that would not let one piece of evidence disappear. Every reasonable attempt to erase the signal had failed, until the only explanation left was the universe itself.